Hi there, Philip from Mindcode here. In this video, we'll be working together on the implementation of the feature to move the player and also to rotate the player in the direction of the movement. So you can see it right now, player will be able to move and also rotate in the correct direction. Okay, of course, you don't need to code along. You can just maybe watch if you want, and to see a solution, I think it's not necessary to code, but I find it better if you would code along with me. First of all, we need to initialize our project. So I will close this one. So we'll start from the scratch. And in the description of this video, you can find one zip file. Okay, so if you will open the link included in the description, you should find there a zip file to download called IT example project rotation. So yt-example project rotation.zip. Simply unzip this. This will take just a couple of seconds. And after that, you should already have a Unity Hub, of course. So let's open Unity Hub. And if you're in Unity Hub, you can add here this project. And I am currently using the version of the Unity 2020.2.1 F1. Okay, so I'm using this version of the Unity. Okay, so projects, let's add here a project and let's find here this unzipped project. So for me, it will be example project rotation. So just give me a second. Okay, here it is. I will just open it. And let's open the project. Maybe if you're on a Windows, it will ask you to change the build settings. Just click OK, and this will change the build settings. And this should open the project for you. If you're not seeing this project straight away, maybe you need to go to project. And here in the assets, you have a scene. So just double click this sample scene, and this should open this scene, what you are seeing right now. And that's already actually completed project. So when you will play the game, you'll be able to rotate and everything. So what we need to do in order to start coding, please click on the player. On the player, you should have a player controller script. Simply open the script, so edit script, or you can find the same script also in the assets. Here is a player controller. Just double click this script, and it will open this in Visual Studio Code, or in your coding editor you have a setup in the Unity. All right, so let's start from the scratch. So simple, let's remove everything in the fix update, and we'll be explaining along the way what we are doing. Okay, so let's fix update, let's remove everything. You can leave the rest of the code. All right. So now when you will save this, you will go back to Unity, you will be not able to move at all. All right, so play the game, and now we shouldn't be able to move. Yeah, we are just standing here still. Okay, so let's start to work on the implementation. Okay, back to coding editor. Oh, this one. All right, this one here. Okay, so first thing in a fixed update, we would like to get currently pressed button where the player is pressing on the keyboard, so we can get the actual movement value. So we can get it with the axis from the input. So let's write here float horizontal input, and we will use your input get axis. And already I have a video about the movement where I am explaining the basics. So if you would like to just refresh the basics, you can find it on my channel. All right, I'm explaining the basics of the movement. So with this get axis will get me the horizontal value. So if I am pressing the left arrow or the right arrow, and this value will go from the -1 to the 1. -1 means that I am pressing the left arrow. The 1 means that I am pressing the right arrow, and the 0 means I am not pressing anything. And the same for the vertical. We can get here also vertical input like this. We'll write here vertical input, and we will get here vertical axis, and this applying for the from the forward arrow and the back arrow, and also for a W key and the S key. So if you are pressing the up arrow, this vertical input will be 1. If you are pressing down arrow, vertical input value will be -1. And again, if you're not pressing anything, this will be 0. Okay, so we have these two values. We need to transform them into the movement vector. So let's write here vector3 movement, and we'll simply create here a new vector3 structure. All right, and this will contain from the horizontal input y-axis. We are not interested to, because we are not moving up and down in the 3D space. We are just moving left and right, and the forward and the backward. So 0 for the y direction, and for z direction, this will be vertical input. This will get me movement input, and what we would like to do here, in order to move in all directions same, we'll normalize it. And also I have a video on YouTube about the normalized, where I'm explaining in details this normalized. So if you're interested, just go ahead and watch it. Okay, so we have a movement vector. The other thing here, we'll write here if statement, and we'll check if we are moving. I will say here if the movement is equal to the vector 3, 0, This means the user is not moving at all, and I simply don't want to continue in the execution of this. I will just simply return from here. Okay. All right, and if we have a movement, we can already move. So we have here a rigid body component, and through the rigid body, we have a method called move, and in a move, we can provide a change in the position. So simply let's access here rigid body variable here, so m_rigid body. Let's use here a method. It's actually called move position, call it, and let's provide here the current position of the player. You can get the current position again from the rigid body, and you can get here position. This will get you current position. You will increase it by the movement. Okay, so you will write here plus movement. You will multiply it by some factor because it will be moving very slow. Oh yeah, we can show it later. Okay, so plus movement, and it will also multiply it by time delta. Okay, so time fixed time delta, because this would be executed. This will be executed too often, and this value will be too huge, because the fixed update is executed 50 times per second. So 50 times per second, you would update position rapidly. So when you are getting here the fixed delta time, this will get you the time of the frame. This is very small value. It's actually 0.02. So when you will multiply it by the movement, this will decrease the movement. So this will also decrease the entire move. So it will move like this. Let's go to Unity. You can play the game, and you will see now you will be moving like this. All right, super slow. And you can see what will happen when you will actually, let's go back here. What will actually happen when you will remove this fixed time delta. All right. This will be actually super fast and not very playable. Okay? Because you're increasing in every frame, and the change will be, yeah, too big. Okay, that's a very fast movement. All right, but also these things of the movement, I'm explaining in my movement video, which is already on YouTube. So we need to simply lower the movement value, because movement value is going from the 0 to the 1. You can imagine if you are moving every second, you are increasing it 50 times, because you're executing this 50 times per second. So every frame, you are increasing this movement plus 1, 50 times per second. So you are going basically 50 meters per second if you are just pressing the forward arrow. So that's why we need to lower this movement. So it's a time dependent and not a frame dependent. So time, fixed time delta. You will see it often in Unity. All right. And this movement was still slow, so what we need to do here, we will multiply it by some speed factor, so let's say by 10. And good practice would be to store this variable, to this value into variables. So let's say here, we already have his speed modifier. I will remove it. And actually, we have here already public float speed. You can see 8. So I can just simply get this speed, and I can multiply here by the speed rather. Okay, and now I should be moving 8 units per second. Okay, so when I will play the game, I will be moving 8 units per second. Okay, so it's this nicely smooth, relatively slow movement. You can increase it also in the editor when you will click on the player. And here you have speed, and you can increase the speed to some higher value. All right, so that's the movement. Very simple. Now we need to handle rotation. This will be quite, it will be more complicated for most of the starting programmers. We'll be talking about the quaternions, and that's something that's quite hard to understand at first. So what we need to do in order to rotate the player. Okay, so first I will store here, I will look for a rotation. Okay, so rotations you are keeping usually in quaternion format. So you will write here quaternion, and let's call this target rotation. And you will use here quaternion class, and on this class you have a method called look rotation, and you will look for a rotation of your movement vector. This will get you rotation in the quaternion format. Then you will reassign this target rotation. Actually, this should already work. I will show it. Yeah, this should already work. So, oops, like this. All right. So I can access here again the method on rigid body, and there should be move rotation. And to rotation, you need to provide a quaternion. Yes. So this target rotation, and this should already rotate the player. So let's save this. Let's go back to Unity, and you should be already rotating the player here. So we'll play the game. I will see already I'll be rotating, but this rotation is very fast. When you're clicking, going left and going to right, you can see this change is happening immediately. So yeah, if you prefer such a behavior, that's okay, but we can improve it. And guys, by the way, if you're looking for the full course where I'm explaining the details from the scratch in the many details, also mathematically and also by the drawing on the 2D space, you can find such a course on my website if you're interested only. Okay, so you can find it on academy.einecode.com. All right, here it is, and here is the course, the new one, the complete Unity guide, 3D beginner to RPG game dev in C#. So here's a full preview, normal RPG game with a full, with normal models, combat system, quest system, dialogues, and yeah, lots of features actually. All right, but that's just the off topic. All right, so let's continue. All right, so now we have a problem that we are rotating too fast. If you would like to slow the rotation, we can reassign our target rotation. And we can use here a method again. This method is located on a quaternion. It's called rotate towards. And to this method, you need to provide the 3 values. You need to provide your current rotation, which is our transform rotation. Rotation in which you would like to get to. So this is from rotation to rotation is our target rotation. And also the maximum change in a degrees, okay? How fast you would like to change this rotation, basically. And I will say here for now 360 degrees, okay? And again, you need to multiply it by a fixed time delta. So time, fixed time, delta time, like this, and semicolon here. Okay, and this will create a smoothened rotation, and your object will be able to rotate 360 degrees per second. Will be maximum change in the rotation. So play the game. You can see now you are nicely rotating the direction, and that's the basically entire solution. So let's get back here. You can play with the value here, and also I would suggest you to store this value in some public variable so you can change it from the editor. If I will lower these values, I will say here the maximum change per second is, let's say, just 10 degrees. This would happen super slow. You would see the change in the rotation will be too small because we can change only 10 degrees per second. So this change will be like this. We are going super slowly. So I prefer to store here this 360 degrees. Yeah, preferable. You can store here max angle change, and you can store it in a variable. And okay, but I would like to draw here on a 2D grid so you understand how this works, also how the target rotation works. So that's already completed solution how to rotate the player. If you are interested into now additional details, how to get this mathematically or how to imagine it on the 2D system, I will be explaining it right now. Okay, so for this, I will go back for a Unity for a second, and you can imagine this view from top to bottom. So we have this view. So we have this coordinate system like this. I will show you. We'll get here. So here is the x-axis, right? And here is the z-axis here. So you can imagine it from the top to bottom. Here is the z, how we are moving on the z-axis. And here is how we are moving on the x-axis. And our movement vector is either, this movement vector we are getting from horizontal and vertical has a maximum value of the 1 and the minimum of the -1. All right, so if I am moving, if I'm pressing just the right key on the keyboard, I am just increasing this horizontal value by 1. So I'm going by 1 here to the right. Where I'm pressing only up key, I'm going by 1 here. All right, when I'm pressing the both keys, I'm getting here 1 and 1, and I'm going this diagonal direction here. Okay, so I'm getting here, this is a 1, 1 movement vector. Okay, you can actually see it also when we will be debugging our code, so you can see this vector. Also here, let's write here debug log, and you can debug log here this movement vector, and you will see these values will be just changing depending on how you are moving. If you are going to just to purely right side the movement vector, the x part here will be 1. Let's play the game and just move the right side, and let's open a console, and you will see when you will just move the right side. Let's click here collapse, please. Okay, and let's click here just the right side. You will see you are increasing only x on the 1. When you will move just a purely left side, you are increasing the x -1. When you are moving purely forward, you are increasing z by 1. And when you are going down, you are going -1. When you are pressing the up key and the right key at the same time, you are getting 0.7, 0.7, because you are normalizing this vector. Okay. So that's basically what I have drawn here. Okay, so we are going either here 1 when we are pressing the right key, either -1 when we are pressing the left key, up forward direction the Z1, pressing down key, here we are going -1. Okay, now let's explain how rotation works. Now we can actually switch to the other view, so it will be easier to actually draw for me. Okay, so let's imagine it like this. All right, so here is a coordinate system, right? So let's imagine our player is here on this position here. Here is our player, and the movement vector we are pressing is 0.7, 0.7, as you could see when you are pressing up key and the right key at the same time. So I can say that 0.7, 0.7 is somewhere here. Okay, so that's the 0.7, 0.7 when we are pressing only right and up arrow and the right arrow. So this is 0.7 and 0.7. All right. Okay, so imagine this. We are moving this 0.7, 0.7. So our movement vector is this 0.7, 0.7. And then we are looking for a rotation. To log rotation, we are providing just a movement. This is 0.7, 0.7. And the log rotation is telling us how much we need to rotate the forward vector. Forward vector is this vector here. Forward vector is always 0, 1. So how much we need to rotate the forward vector, this vector here, in order to get to the position 0.7, 0.7. And that is exactly this. This is exactly 45 degrees. This is a 45 degrees angle. So what I'm saying here, in this line of code here, target rotation, this will keep the value that I have to rotate 45 degrees on the y-axis. Okay, so this is just saying me apply rotation to the player when you are pressing up arrow and the right arrow, so you are going this diagonal 0.7, 0.7, you need to rotate 45 degrees. That's basically what we are keeping here in a target rotation value. All right, and that's already we can apply to move rotation. This will rotate the player, but if you would like to see the change in a transition, this we can apply. We can also fill in into rotate towards, where you can provide the current rotation of the player. Target rotation will be 45 degrees, and this change will happen over this time here. So it will allow that you can only rotate this actual 360 times multiplied by fixed time delta. So this will be, if you will put it to calculator, so this will be a maximum allowed to change per frame in which you can rotate. I told you fixed time delta is 0.02, so I'll calculate it. Calculator, so 0.02 multiplied by 360 degrees, it's a 0.2. So you can, in one frame, you can maximum rotate 7 degrees. Okay, so that's why we are rotating slowly as we are moving into specific direction. But I would like to show you that indeed here we will be rotating 45 degrees when we are going up and the right. So what we can do here actually to see actual angle, I can write here debug log. All right, we can remove this first debug log of the movement. And debug log here, target rotation. All right, and Euler angles. This will get you angle in normal format, because quaternion is quite hard to understand. So if you would like to debug your code, it's a good idea just to provide the Euler angles to quaternion, and this will get you actual rotation in degrees. Okay, so let's debug log it, and let's go to Unity. And yeah, let's run this. And only thing you need to do, just press the up key and the right key. Okay, so let's press up key and the right key. And you can see here, indeed, in this last console, it's a 45 degrees on the y-axis. So that means we are rotating 45 degrees. You can see we are still in this 45 degrees rotation. And you click on the player, you can see this rotation of a 45 degrees is applied. Okay, so that's the basically explanation behind the log rotation, which is most important here. It's saying what rotation should be applied when we would like to move the forward vector in the position of the movement vector. So as I draw it here, all right, okay, this is a forward vector. Forward vector is always 0, 1, and our movement vector in this case was 0.7, 0.7, so somewhere here. All rotation needs to be applied, so this vector here will go into the position here, and that's exactly 45 degrees. It's computed by the Unity, but you can also compute it on the paper by yourself. This is just the basically right triangle. If you know the values of the 0.7, 0.7, you can compute everything by yourself. But I'm explaining all of this in the lectures and in some of my videos on YouTube. You don't need to really need these deep explanations if you are programming, but it's a good benefit to understand this, how it works behind the scenes. Alright guys, so that's the entire movement of the player, and that should be it for this video. All of the other things I'm explaining in the course or in my other videos on YouTube. I just recently started with Unity videos and I'm really enjoying it a lot. So you can expect more videos from me. That should be it from this lecture, and see you in some of my other videos. Cheers, guys.